Hello everyone. Today we are going to talk about Chapter 2, Unit 1. Unit 1, Chapter 2 consists of the chemistry of life. The chemistry of life, that means we are going to talk about matter. So, what is matter? Matter is something which has mass and occupies space, and it consists of atoms and molecules. Matter cannot be created nor destroyed, and you can see that it is made up of several one or more elements and organized into atoms and molecules. An element is the smallest substance which is on the periodic table and cannot be broken down by chemical means into other substances. What that mean? When you eat something and you go under the process of digestion, when you break down those complex compounds into simpler substances. But element is such a simple substance which is made up of only one kind of atoms. You cannot break it down into further other substances other than atoms. All living beings, such as nuet or plant, are mostly composed of six elements. The word mostly is here because there are some micro elements which you take through your multivitamins and all those tablets. So, what are those? Carbon, hydrogen, oxygen, nitrogen, and phosphorus and sulfur. So, you can see those different elements by which all living beings are made up of. Now, it is a good idea that you can always study first 20 elements in your periodic table. This thing is known as periodic table, and it is very important that you get yourself familiarized with periodic table. Periodic table has only got elements, and then you can see that this is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18, 19, 20. So it is a good idea that you memorize first 20 elements. And once you memorize first 20 elements, you must know what is their atomic number. So you can see when you talk about their atomic number, it is 1, 2, 3, 4, 5, 6, and they are going in order, sending order. So you can see that on the top is atomic number, and then these small letters, they are symbol. So these are shorthand of all elements. H stands for hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, calcium, and potassium and calcium. So make sure you know their symbol first 20. It's a good idea to memorize first 20. And look at the bottom, they have their atomic weight. So this whole thing is known as periodic table. To understand this, you have to learn about these elements. Now, we will talk about the atoms, because here we have elements and they have atoms. So keep in mind the periodic table has all elements arranged systematically according to the increasing atomic number. Now, you will be seeing all these atomic numbers in increasing order, and atomic number is equal to number of protons, which we will talk about in next slide. Now you can see in case of an atom, that is the smallest particle which cannot be which is indivisible and cannot be divisible into further smaller parts. So you can see it is the smallest piece of an element. So if we talk about an element, for example, this is an element. Say this element is a carbon. The reason I said carbon, because you can see six protons and six neutrons. And let me go back and check that, like carbon atomic number 6, 6. You can see electrons, 6 protons, and 6 neutrons. When you add that, that is atomic weight. You must know how to do that. In my virtual class, we will talk about how to calculate mass number. Now you can see parts of an element. So parts of an element is an atom. Now parts of an atom. So at every single atom consists of protons, neutrons, electrons. So electrons are the one which are surrounded by the atomic nucleus. So you can see that security guards are all your electrons. So where are these present? they are present in the shell. You need to know this word shell. It's coming up in the slides. And what do we have in the center? Nucleus. You can see protons and neutrons. So where do they live? Protons and neutrons, they live in nucleus, and electrons are orbiting around the nucleus. So they are usually security guards. Now, what about their nature? Protons are positively charged, neutrons are neutral, and electrons are negatively charged. So, you know what happened? Once upon a time, a neutron walked into a bar. And what did the bartender say? For you, free of charge. Because neutrons are neutral. Let's move on. Now you can see that electron, neutrons and protons, they are negative, is the same repetition, and they are surrounding nucleus, and it is present inside the nucleus. Periodic table. Now, how to determine the atomic number? You must know this. It's going to be somewhere in your test. So make sure that you know the atomic number. What is equal to the atomic number? Proton is are equal to the atomic number. For example, if I'll ask you what is the atomic number of aluminum, you'll say 13. So how many protons are present in aluminum? 13, 1, 3. Same here in carbon. Carbon has 6 protons and carbon's atomic number is 6. So, point to be noted. Let's see next one. Proton neutron determines the mass number. So we were talking about how to calculate mass number. So you can see that when you have here protons and you have neutrons, so mass is total of this. If it changes in any case or in isotope, you add them, that is going to be 12. So why 6 plus 6 is 12. So how do you determine mass number? By adding protons and number of neutrons. Must note down this and memorize this. Now, what are isotopes? Another very important concept. Iso means same, the number of neutrons. So, you see, when one element shows three different types of mass number, you can see 12, 13, 14. What is changing here? Only the number of neutrons. Protons never change, whether it's an atom or an ion. One thing which stays stable, same all the time is protons. But what are isotopes? Isotopes are those elements which have same number of protons but different number of neutrons. So you can see there is a definition of isotopes. You can define it in a different way, that you can say that elements having the same atomic number but different atomic mass or mass number, because mass number changes with change in neutrons. So you can define in any way as far as you know the concept of isotopes. Okay, same thing, neutron differs. So elements have a different mass because of number of different neutrons. You can see that. And the one example is carbon here, 12, 13 and 14. So carbon has three isotopes. Atomic weight, like you saw on the periodic table, atomic weight. So atomic weight is the average mass. For example, we said 12 because that was even 12 and 12, and the mass number is 13 and 14. So 99% of carbon isotopes have mass number 12. So they are, when you see a decimal point and few digits after it, we call it as an atomic weight. But mass number is always a whole number. Now we talked about elements, we talked about atoms. Now we have to talk about bonding. Sometimes you have like elements, they are more than one atom and they are organized into molecules. So how are these molecules formed? Molecules are formed by chemical bonds. So you can see that in this molecule, this is a water molecule, you see that hydrogen bonds H2O. So oxygen and then two hydrogen. So each of these water molecule is composed of two hydrogen atoms and one oxygen atom. Now, We talked about protons and neutrons to find mass number. We did not say anything about electrons. Now, when you have chemical bonding, these people, your security guards, they play a very important role. For example, you can see atomic number 1, atomic number 6, 7, 8, 15. This is phosphorus, you can see. So you see that how many electrons the purple color is 1. And then outermost I'm talking about, the outermost, you can see 1, 2, 3, 4, 2, 3, 4, 5. So you have to see the outermost electrons. When you look at the periodic table, you will see the group number will tell you the outermost electron, these security guards. So the number and distribution of electrons around an atom determines whether or how atom will react with other, because the outermost will always have two no matter what. And then as we move on, you can see 8. So the cycle goes on 2, 8, 8, 18. So you can see that here 1, 2, 3, 4, 5, 6, 7, 8. So 8 is a shell. When they are complete, they are not going to exchange their electrons and there will not be any chemical bonding. That means bonding has been already satisfied. Electron exist in energy shells. I did say that shell word is very important. So you can see that these are shells. So shells exist at various distances from atomic nucleus, and the farthest from the nucleus is important for the bonding. That's why we were counting only the outermost shell. So in a neutral atom, number of electrons are equal to number of protons, but when bonding takes place, electron changes. I am repeating this. This is a very important concept. Atom is always neutral, but when chemical bonding takes place, these outermost electrons they exchange their electrons either by covalent bonding or ionic bonding, and then they are the one they go here and there. So shell from the farthest from the nucleus is important for bonding, which is chemical bonding in order to make a molecule of a compound or of a molecule of an atom. That is element, not atom, that is an element. Now, unpaired electrons form bonds with other atoms. Now, you can see atoms are always stable. So, something which is unpaired, which you have more extra, have no vacancies, they are less stable. You can see these arrows here. So vacancies make more atoms more less stable. For example, this guy needed two, but was only one, so there was a vacancy here. There was a vacancy here. Carbon needs like either they need two, that is your hydrogen, and then eight. The next shell to be a stable, an atom to be a stable needs 8 in the outermost. So if there are no 8 electrons, they create a vacancy and they are the one which are reactive and ready to jump and form the bonding. Now you can see here 1, 2. You can see 1, 2, 3. So these are the vacant and they need to be filled during bonding. You can see here carbon has 4 vacancies in the outer shell, hydrogen has 1 vacancy as I showed you in last one. So in case of carbon and hydrogen, if we combine these two, you can see carbon had 4 vacancies. So you filled with 1 hydrogen, then there was 1, there was 1, there was 1. So you needed 4 hydrogens to make to fill carbon to make carbon stable. Carbon 1, hydrogen 4, and the molecule is CH4. So, one atom of carbon, 4 atoms of hydrogen, they formed a one molecule of methane. If you remember in previous chapter, levels of hierarchy starts with atom and molecule. So here different atoms they combine to form a molecule. So what is a molecule here? Methane is a molecule here. Now, chemical bonds links atom into molecules. That's what we showed you. Now, this is known as bonding. We haven't talked about what kind of bonding, but these are bonds. When two atoms they react with each other, they exchange or share their electrons, and that is known as bonding. Covalent bonding, that is one type of bonding. We talked about atom, we talked about molecule, we talked about bonding. Now, what type of bonding is covalent bonding? Now, you can see that it is by sharing of electrons. Memorize this, sharing of electrons. Why sharing? Because there is no only one, there wasn't any one sided giving up the electrons. That hydrogen has got one empty space and carbon has got one, so they shared, these two shared, so that's why this has got two and this has got two, so the one hydrogen was satisfied. Same process took place here, same process took place here, same process took place here, and that's how methane molecule was formed, by having a covalent bond. So covalent bonding takes place by sharing of electrons, outermost electrons. You can see when you have a double covalent bonds, sometime in case of organic molecules or in elements, double sharing takes place, and this is an element, and we write it like O2, that means two oxygen atom, 1 and 2, and you can see electron valency energy shells, and they share their electrons and they form a double bond here, and you can see double bonding takes place, which is known as two oxygen, and these two oxygens, they are sharing electrons, double covalent bonds by sharing. In case of oxygen, hydrogen, hydrogen is single sharing, nitrogen is triple, but they are all covalent bond, but here it is oxygen. Water is found by covalent bonding. Water is a very important topic for this chapter, but it is found by similar to hydrogen, and then you can see one oxygen. So oxygen has got two vacancies here, hydrogen has one vacancy, one vacancy. So by sharing, molecule of water is formed, H2O. Now, why this bonding takes place? There is a property of all atoms to ability to attract electrons, that is known as electronegativity. When we talk about periodic table, in periodic table we can always talk about electronegativity, that how electronegativity changes, and due to the difference in the electronegativity of carbon and hydrogen, and then oxygen and hydrogen, these bondings are taking place. So electronegativity is a process by which, it's a property by which the atoms are able to attract electrons. Electronegativity differs, and that is how covalent bonding takes place. You can see large and then small. Electronegativity differs, and we talked about this, how it differs. Now, in case of periodic table, when you move from left to right, you can see there is a electron change in the electronegativity. Electronegativity was low, that means these were all positive, and then this side was very negative. Do not count this group. These are noble gases. They do not have any reactivity. That's why we have neon sign, we have those helium balloons, and then we have like things which are non-reactive. They do not react with any metal, these elements, noble gases. So highly electronegative elements are fluorine, chlorine, bromine, iodine. This group is highly electronegative. Who is a highly electropositive? This group. Lithium, sodium, potassium are very, very positive. So electronegativity is increasing. That's why you saw that hydrogen was able to react here, carbon was able to react with hydrogen, and carbon dioxide, nitrogen dioxide. You cannot reverse the process, but you can do this because they have a change in their electronegativity. Due to the change in electronegativity, they react. And when very positive element reacts with negative, a different kind of bonding takes place, which we will see in other slides. So we just talked about covalent bonding, which is chemical bonding. Same thing here. Some atoms are very close to each other, so they have similar electronegativity. You saw that, and I gave you this example. Now, polar covalent bond. There are some polar covalent bonds. The best example is a water molecule, and you can see due to their change in electronegativity, oxygen and the hydrogen atom or water molecule they react. Oxygen attracts electron more strongly than hydrogen. That's why, because it's on this side and this is on this side. So, which is more electronegative? Hydrogen. Oxygen is more electronegative than hydrogen. That's why the reaction between these two was possible. Otherwise, metals react with nonmetals, and there is no reaction between two nonmetals until unless there is a change in electronegativity. Some atoms have partial charge. Since the electrons spend more time near oxygen, the oxygen atom has slightly negative charge. And then you can see that they have the partial charge. You can see that how they are attached. Here, hydrogen atom slightly positive, oxygen atoms negative. Since the electrons spend less time near hydrogen, hydrogen atom has slightly positive charge because it's on the left hand side, and these are known as the previous one also known as partial polar charge and polar bonds. And then you can see here we are using word there, polar covalent bond, because there is a difference in the electronegativity. Water is held together by polar covalent bonds. Repeating this point, water is held together by polar covalent bonds. The charges between oxygen and hydrogen in water gives the bond polarity, and they have different electronegativities. Polarity in water molecule creates hydrogen bond. We talked about the molecule. Sometime they not sometime in case of water it's always water to water. When you take a water from two different places, you mix each other, you cannot differentiate because they bond so closely to each other. You cannot find out, you cannot separate that this water from this pond, this water is from this pond, this water is from tap water, this water is from pond water. You once you mix them, and that is due to the result of hydrogen bonding. And this is a hydrogen bond. A weak hydrogen bonds are together, and when you try to pull the water droplets away, they are going to still stick to each other because of slight positive charge on the hydrogen atom of one water molecule and slightly negative charge on the oxygen of neighboring water molecule. So they are like very tightly bonded together. And that is how the hydrogen gives water its emergent properties. Now you can see very high electronegativity forms ionic bonds. You can see that electrons completely transfer to highly electronegative atoms. Now, before we talk about these, pay attention to this. This charge defines that atom to each other. Now, what charge we were talking about? Electronegativity. This side, as I said, positive, this side I said negative. So due to this, second type of bonding we call as ionic bonding. So no sharing of electrons. Here you can see the transfer of electrons. So this charge attracts electrons. But who is going to give and who is going to accept? You see that sodium was on the left hand side, chlorine was on the right hand side. So, being positive in nature, it's going to give one electron here, and then the bonding is formed, and then that is NaCl. But why only one? Because that was unstable. This was making it unstable, and this was 8. 8 was, this shell was stable with the 8 electron, and I did mention that 2, 8, 18. So most of your elements in your course have 8. So that is going to jump ahead. This was 7 outside, so it will take 1. So this is 8. So now you can see that outer shell has 8, outer shell has 8. So an ionic bond is found between sodium chloride, and the bonding due to transfer of electron is known as ionic bonding, and this takes place between metals and nonmetals. How do you know which are metals and nonmetals? Go back and look at the periodic table. Atoms with ionic bond become very stable, as I showed you how they became very stable, and this is a lattice structure where you can see that there are no vacancies. That's why they became very stable. That's why you can keep it. Sodium chloride, it's neutral, you can put it on your skin, nothing is gonna happen. But if you touch a sodium, it will burn your skin. It's very strong. Sodium is kept in oil because you cannot leave it outside. If you leave a sodium metal outside, it's going to be very reactive, sodium oxide, and you put it in water, it catches fire. It is so reactive as soon as it comes in contact with oxygen. These are certain properties of water. Water is essential to life. It is cohesive and adhesive because these it can attach to anything and it can attract anything. It's an excellent solvent, which we call it as a universal solvent. So all inorganic compounds can be easily dissolved in water. It regulates temperature. When you get very hot, you start giving out water, which is sweat evaporation, and when you are sweating, it cools down. The evaporation gives you a cooling effect, which regulates your body temperature. Water expands when it freezes. You see that those ice cubes, they float on the top of water or liquid because it is less dense. So when water freezes, it is less dense, and density is less. When it is less dense, density is less, so it floats on the top of water. Water participates in chemical reactions needed for our life. Our body is made up of 70% of water, so all reactions taking place in our body requires water. So when different reactions taking place in our body, they produce some water, which is metabolic water, and that helps in are different reactions because it is more soluble. So those reactions, they help in carrying those life activities faster in water. So water takes part, water plays a very important in all chemical reactions of our life. Now we talked about bonding and functions of water. What is water? Bonding in water. Now another chemical aspect of life is hydrogen ion concentration. Hydrogen ion concentration is known as pH. pH is very important because we need to balance pH of our body. So I'm not going to go over all the scale. You can read it from the other PowerPoint. But see what happens. We have like a acidic, neutral, and basic. So you can see acidic solutions have a low pH, and that is anything less than 7. You can see they are all counted as acidic. 7 is neutral. Anything above 7 is basic. You can call it as basic. And bases have more OH ions. Acids have more H ions. For example, hydrochloric acid, hydro sulfuric acid, nitric acid, and the acid our body produces is hydrochloric acid. That's why when you don't eat, your stomach produces hydrochloric acid, and people have like acid influx, and they have to take antacids and those like Pepto-Bismol and Tum-Tums and different kind of thing to increase these ions and to suppress these, because when you take add this with this, it is HOH, and HOH is H2O, water, so it neutralizes. You can see if organism stays too far from its optimal pH, it dies. That's why we have to have a normal pH in our blood, which is known as homeostasis. In case of that, that is your pH 7. So our blood has a different pH, our body has a different pH. So stomach has a different pH. When pH is too high, and that it releases hydrogen ion. When pH is too low, hydrogen ion needs to raise the pH. When pH is too low, you need OH ions. You can see that if an organism stay too far. So buffer solutions help maintaining our body pH. So OH is basic, H is acidic, 7 is neutral. Anything less than 7 is acidic and above 7 is basic. Third part of our body, chemistry of our life, we made up of different molecules. Organic molecules are biologically important. For example, we have carbohydrates, proteins, fats, and different types of nucleic acids. These are major molecules present in our body. And the simplest organic molecule is a methane. And recall that information, methane is made up by covalent bonding and by sharing of electrons, CH4. These are some examples of organic molecules in our food. Carbohydrates, protein, fats are mainly our organic molecules. So when we talk about organic molecules, we do have a smaller molecule which built up a bigger molecule. So what are monomers? A single unit. And then polymers, when we have a chain of those molecules. For example, carbohydrate monomers, sugars, and then monosaccharides. Proteins, you will have amino acids. Nucleic acid, you have nucleotides, monomers. So you can see that a one unit and then many units then can form polymers. Poly means many, mono means one. There are different reactions which synthesize which takes place to join monomers. One type is known as dehydration synthesis. Dehydration means losing water, synthesis means formation. To make a polymer and in the presence of enzymes, water is released and monomers are combined. So that is a dehydration synthesis. And a big molecule monomers they make a polymer. Hydrolysis breaks polymers apart. This is opposite. Hydro means water, lysis means breaking down. To digest, that's what is happening in our stomach, what you eat breaks polymers into monomers. You can see that here it was water is added and then two different molecules are formed. So breaks polymers. So this was a polymer. You saw that long chain and these are the monomers. So that is opposite. And then water is added here, helps in breaking, it is added, it helps in breaking the molecules and then giving them those vacancy filled and then monomers are formed. In case of carbohydrates, the single unit, the monomers are monosaccharides. The single unit are monosaccharides. Mono means one, saccharides means sugar. So they are simple sugars, and these are the structures you are not required to memorize, but it is good to know what is glucose and what is fructose and how do they look like. Dehydration synthesis and breakdown. This is how the reaction looks like. Hydrolysis separates disaccharide and the dehydration binds the monosaccharide together. Complex carbohydrates. You can see cellulose, starch, and glycogen. Cellulose is present in the cell walls of all plants, and starch is energy, like you see that potato and other stuff. They are starchy. Your bread is made up of starch. Glycogen is stored in liver and muscles. These are all your examples of polysaccharides, and you must know these examples. Second form of organic molecules are proteins. Proteins are like whole our body consists of proteins. You can see the all structural components. They are proteins, collagen, which is present in your skin, hair, nail, and it is present beneath your skull. So as you grow older, automatically we lose collagen. Contractile, this helps in movement of our body. Transport, membrane proteins, and these are the one they help in transporting different substances in our body. It is also in membrane channel proteins. Storage, they helps in different types of food storage. For example, your egg protein enzymes, they take part in different chemical reactions in our body, and they are known as biological proteins. Now, what are the building blocks of proteins? Amino acids. What are the building blocks of carbohydrates? Monosaccharides. Each amino acid has its own chemical bond and physical properties. You are not required to memorize these, but you must know these. Protein synthesis and breakdown. You can see again the hydrolysis and dehydration reaction. And you can see this is amino acid. These two are combined. When dehydration synthesis, peptide bond, the water is released. In case of hydrolysis, water is added in the formation of breakdown. So the process is going this way and the process is going this way. So you can memorize both the equation by looking at the same reaction. Polypeptides. Poly means many peptides. When our body folds proteins into different structures, it is known as polypeptides, and it can be done by a primary structure, secondary structure, or tertiary structure. And you can see that normal denature. This is how they are formed, and when you heat them, they uncoil. That's why you don't cook egg too much once it is burned. And protein is non-functional, but protein is functional. Denatured protein lose their shape. You can see primary structure, secondary structure, and tertiary structure. You can see protein tertiary and quaternary structure, and it depends on their foldings. Another type of macromolecules is nucleic acid. In my previous lecture, I did not use what is DNA, deoxyribonucleic acid. So that was our genetic material, and RNA is ribonucleic acid. So these are our substances, nucleic acid present in our body. The primary structure of each protein cell is determined by their nucleic acid. That's another type. And what are the building blocks? The monomers, nucleotide. And these nucleotides, they are made up of phosphate group, a sugar, whether it's if it is a DNA, it is deoxy, but if it is RNA, it's just ribose sugar and a nitrogenous base. So you can see that nucleotides have nucleic acids have building blocks of nucleotides, different nitrogenous bases in case of DNA and RNA. So this point to be noted that thymine is the one which is present in DNA, uracil is the one which is present only in RNA, but your adenine and guanine, they are always same. So they are, and cytosine. These three are everywhere in DNA as well as in RNA. But the exception is this and this, the thymine as well as you have uracil. Nucleic acid synthesis and breakdown. You can see that this is how synthesis, water is adding, water is released. Lipids, another macromolecules, hydrophobic and hydrophilic. You know those fat molecules cannot mix with water. So you can see that hydrophobic molecules, hydro means water, phobic means heat. They do not dissolve in water. Unlike carbohydrate, protein, and nucleic acid, they do not have built from a chain of monomers. But you can say that after digestion, they can form fatty acids. Triglycerides, another example. Steroids, classes of lipids, first class, fats and oils. These are different groups of triglycerides, some fatty, saturated, unsaturated. It depends on double and triple bond. You can see that here all bonds are satisfied, so we call it as a saturated. Here you will see double bond. These are unsaturated. So you can see saturated and unsaturated. You can see unsaturated. Waxes are another class of lipids, and their chemical composition is little different. In nature, waxes form waterproof seals such as cuticle and stop leaves from drying out. Steroids are important lipid molecule. Cholesterol is present in our body. It is a part of cell membrane. It blocks. That's why the higher level of cholesterol is not needed in our body. And then testosterone is another male hormone, which is also one kind of steroid. Okay, this concludes our chapter 2 and the chemistry of life. This is a lot, but this is your overview. I will let you review that and we will see you in next chapter. Thank you.